This is section 6.1 on working with triangles and solving equations. I hope that by the end of this lesson, you're going to be able to identify strategies to use or tools when seeking information about triangles, and that you can use your understanding of the order of operations and inverse operations to solve and rearrange equations. You've had a chance by now to work through the corner-to-corner task, which was a chance for us to review the Pythagorean theorem. The Pythagorean theorem allows us to find the side length in a right triangle if we know two other side lengths. The question you're working on right now is hopefully number 2 here, the Great Pyramid of Khufu. And the Great Pyramids of Khufu are in Egypt in the Valley of the Kings. It took 10 to 20 years to build and is made of 2.3 million blocks of limestone and granite. Pretty crazy. You can see the camels having a little conversation here. I gave you a diagram to represent the situation, and we'd like to know which of those two angles is the greatest, the face-on angle or the edge-on angle. So the edge-on angle would be one of these edges. If you were to look at the angle of one of these edges, you could compare it to one of the face-on angles, and there's a line up here in red that represents one of those angles. So face. Now, for us to find either of these angles, we're going to have to look at the triangle that they can create. So we've given you that triangle here in red, and I put a little square down here just to identify that it's a right angle here, a 90-degree angle. And I believe that the tools you have so far are the Pythagorean theorem, which isn't very helpful for us because we already know all 3 side lengths. And I don't believe yet that you have many tools to help you find an angle. This is the angle of interest here, the one that we're looking to find. But I don't know if you have the tools yet to find that angle. The other angle we're looking at, let me see if I can draw this line in here. Going from the center of this square out to the corner, we could have a line here. It makes a right angle with the vertical line at the center here, and that would create this angle between the edge and the base. And that angle here, we know the height of the opposite side, but we don't know any other information. We could use Pythagorean theorem to find out this distance here. I'll call it x. But even if we have those 2 side lengths, it's still not going to help us find the angle at this time. So unfortunately, we can't actually go any further with this question because we don't have the tools. Luckily for you, in this unit, we're going to learn about a new tool that will help you find an angle or a side in a right triangle when you don't have another angle. So, trigonometry, spelled like this. And it's a tool used to find sides and angles in right triangles. To use trigonometry, we're going to need to review our equation solving skills, and much like with the Pythagorean theorem, we will also need to use equation solving skills. So trigonometry and the Pythagorean theorem are both tools that we're going to use in this unit. And like I said, we're going to need to review our equation solving skills. So let's do that now. Solving equations. For number 3 here, what's the solution to 2x plus 7 is equal to 11? Go ahead, pause the video here, and see if you can solve this question. Some of you may have been able to solve this question by looking at it and saying, hey, I need to add some number here to 7 to get 11, and you could probably see that you needed to add 4, and 4 needed to be made up with 2 times some number, so we ended up with x is equal to 2. So you may have rationalized the solution for this in that method, and it's okay here in this situation, but when these get more complicated, we do need to have a proper method to solve equations. And when we're solving equations, we need to look at the order of operations that's happening to the piece of information we're looking for. So here we're looking to find x. And if we look at what's happening to x, it's being multiplied by 2, and there's also adding 7. So order of operations says that we have to multiply first. So the first thing that would happen to x would be we would multiply by 2. And the next thing that would happen is that we would take that new number and we would add 7. And when we do that, we get 11. To solve this, we need to undo those operations in the reverse order. So the inverse operations, that's the undo, and the reverse order. So we started with the last thing, that was adding 7. The inverse of that would be subtracting 7. And then we would go to the previous thing, which was multiplying by 2, and to undo that, we would divide by 2. So let's see how that works. We have 2x plus 7 is equal to 11. Whoops. And if we first subtracted 7 from both sides, we can see that 11 minus 7 leaves us with 4, and 7 minus 7 will cancel out or simplify to be 0. And we have 2x is equal to 4. Then we divide by 2 on both sides, and x is equal to 2. So, solving equations. We need to be able to find the inverse operations. Well, I guess first we need to figure out what's the order of operations of things that are happening to the unknown value. Then we need to be able to undo those operations, and we need to do that in the reverse order. So what does it mean to solve an equation? Well, it means that you need to find a value of the variable that makes the equation true, or both sides equivalent. In algebra, the equals sign is a balance sign, meaning the left side is equal in weight to the right side, and it should be balanced. Both sides should be equal. When we replace the variable in the equation, for example, x plus 3 is equal to 5, with a constant that makes the equation true, it's said to be a solution to the equation. So if we replace this value here, x, with some number, the appropriate number, that makes this equation true, that value we put in for x would be the solution to the equation. So what's your goal when you're solving an equation? Well, when solving an equation, you want to first isolate the variable on one side of the equation, and this can be done by applying the inverse operations in the opposite order, or the reversed order. Now let's check out what that means and practice it a little bit. Go ahead, work on these 4. I'll do the first one here with you, but write the inverse operations in the opposite order for each scenario. So imagine you put your socks on, then you put your shoes on, and then you tie up your laces. So what are the inverse operations? If we wanted to reverse that, we have to start with the most recent thing. We can't take off our socks first before we take off our shoes. And we can't take off our shoes usually before we untie our laces. So the first thing we need to do is to untie our laces. Then we would remove our shoe. And then we could remove the sock. Go ahead, pause the video here, and complete B, C, and D. Okay, for B, put the key in the engine and turn the car on. To reverse this, you would first turn the car off, and then you would remove the key. For C, it says multiply a number by 2, then add 1. So we would take the last piece, add 1, and we would do the opposite. So we would subtract 1. And then we would divide by 2. And for D, we're subtracting 3, then dividing by 5. So the last thing that happened was this divide by 5, so we're going to multiply by 5. First thing that happened was subtract 3, so we then add 3. Let's list the inverse operations. So we have addition, and its inverse is subtraction. We have multiplication, and its inverse is division. And we, just for purposes of this unit, we have squaring. And the opposite of that would be square rooting. So go ahead and work on the practice questions that follow.